Have you ever wondered what would happen if you took a wrong turn in space and accidentally nosedived into a black hole? Would you be shredded into cosmic spaghetti, transported to another dimension, or just evaporate like last night's pizza leftovers? Well, buckle up, brave space traveler, because we're about to take a journey into the most mysterious and terrifying phenomenon in the universe: black holes. Black holes, not your average space pit. Contrary to what their name suggests, black holes aren't just empty voids lurking in the galaxy, waiting to devour unsuspecting astronauts like some sci-fi horror trope. Instead, they're the ultimate space-time anomalies, places where the rules of physics break down so spectacularly, it's as if the universe itself threw up its hands and said, "You figure this out." Black holes were first predicted by Einstein's theory of relativity. But back then, they sounded so absurd that even Einstein himself wasn't sure they could really exist. Turns out, the universe loves a good plot twist, because science later confirmed their existence with actual observations. These cosmic monsters form when a massive star collapses under its own gravity, crushing itself into an ultra-dense core that defies reason. If the leftover core is at least 3 times the mass of our Sun, gravity goes into overdrive, pulling everything inward until it gets squished into an infinitely dense point, aka singularity. And just like that, a black hole is born, a region where gravity is so strong that not even light can escape, effectively making it invisible. But don't worry, black holes aren't roaming the galaxy like cosmic vacuum cleaners, randomly sucking up planets. They follow the same gravitational rules as everything else, just with an extreme, mind-bending twist. The gravity workout plan. Why black holes are fitness goals. If you think Earth's gravity is strong, black holes would like to politely disagree and then crush every atom in your body into oblivion. To put their power into perspective, let's start small. Imagine standing on the Sun. You'd experience a gravitational force 28 times stronger than Earth's. In other words, if you weigh 150 pounds, 68 kilogram, here, you'd suddenly weigh over 4,000 pounds, 1,800 kilogram. So unless you're benching elephants, you're not standing up anytime soon. Now let's crank it up to black hole levels. Picture cramming 4 entire suns into a space just 24 kilometer, 15 miles, across about the size of a short city commute. The gravity in that region would be so absurdly intense that not even light can escape. That's right, light, the fastest thing in the universe, is literally too slow to outrun a black hole. And in case you're wondering, no amount of gym time, cardio, or protein shakes will help you fight back against this level of gravitational flex. The moment you get too close, you're getting spaghettified, stretched so thin that even your atoms would be stripped apart. Talk about next-level body transformation. How to spot a black hole. Black holes are basically the universe's best hide-and-seek champions because they absorb all light, making them completely invisible. But don't worry, we got tricks to spot them without accidentally drifting too close and getting turned into cosmic spaghetti. One way to detect them? Gamma-ray bursts. When black holes snack on unfortunate space debris, stars, or even gas clouds, they generate powerful, high-energy radiation. These bursts are like cosmic flares, signaling something just got obliterated here. This phenomenon was famously linked to Stephen Hawking, who predicted that black holes emit radiation over time, now called Hawking radiation. And in case you're wondering if we have a black hole neighbor, the answer is yes. A supermassive black hole is chilling right at the center of our Milky Way, known as Sagittarius A. But before you start packing your bags for interstellar evacuation, don't worry, it's a comfortable 265 quadrillion kilometers away. That's 165,000 light years. So unless black holes suddenly learn teleportation, we're safe for now. Falling into a black hole, the ultimate one-way ticket. Falling into a black hole is the ultimate one-way trip, where the laws of physics twist into a bizarre nightmare. As you cross the event horizon, the cosmic order of no return, light itself can't escape, and neither can you. Nearby, you'd witness a swirling, distorted sky as gravity warps space-time around you. If you plunge into a small stellar mass black hole about 9 miles across, tidal forces would rip you apart instantly in a gruesome process called spaghettification. Your body's stretched into cosmic noodles before even reaching the event horizon. But if you opt for a supermassive black hole, like the one lurking at the center of our galaxy, you'd actually survive the fall past the event horizon because the immense gravity is spread out more evenly. No instant doom yet. Instead, you drift deeper into the abyss, trapped forever in the inescapable grip of an object that shreds the very fabric of reality, your fate sealed as you spiral toward the singularity. where physics as we know it ceases to exist. Inside the black hole, reality bites. Once you cross the event horizon, reality stops playing fair. You're now on a fast track to the singularity, the infinitely dense center of the black hole where gravity is so ridiculously strong that even the laws of physics throw in the towel. What does that mean? Well, your atoms get compressed into oblivion, your existence becomes a mathematical nightmare, and space and time essentially stop making sense. Not exactly a 5-star experience, but here's where things get even weirder. From the perspective of an outside observer, you wouldn't actually fall into the black hole. Instead, they'd see you slow down, getting redder and dimmer, until poof. You appear frozen in time at the event horizon. It's like watching a VHS tape, if you remember those, that suddenly pauses forever. Why? Because the extreme gravitational time dilation stretches time near the event horizon to an infinite standstill for outside viewers. For you though, time keeps moving forward as usual. There's no stopping, no turning back. Inside a black hole, space and time do a mind-bending switcheroo. Space flows forward, while time becomes a one-way street, and that street leads straight to the singularity. No exits, no escape plans, just an infinite fall toward oblivion. Not exactly the thrilling space adventure you signed up for. Is there a way out? Maybe, if you believe Hawking. Stephen Hawking, being the brilliant rule breaker of physics, suggested a mind-blowing possibility. Black holes might not be the ultimate cosmic death traps after all. Instead, they could be portals to other universes. That's right, every black hole might lead to a different reality, where an alternate version of you exists. In one universe, you fell into the black hole, spaghettified into oblivion. In another, you wisely decided to stay home, order pizza, and binge-watch Netflix instead. If Hawking was right, black holes could be gateways to the multiverse, where different laws of physics, alternate Earths, or even completely alien realities might exist on the other side. Basically, falling into a black hole might be the most extreme form of interdimensional travel ever. And here's another twist: black holes don't last forever. Thanks to Hawking radiation, they slowly evaporate over time. When a black hole finally dies, it theoretically releases all the information it ever swallowed. But what does that mean? Would you be reassembled on the other side, or would you just be a scrambled mess of quantum data floating through the cosmos? Would you still be you? That's the real mystery, one that even Hawking himself couldn't fully answer. So, should you jump into a black hole? Should you jump into a black hole? Well, let's break it down. On the bright side, you might teleport to another universe, experience the weirdest physics experiment firsthand, and secure your place in history as the first and only person to attempt it. With the downside, you'll almost certainly die either by being stretched into cosmic spaghetti or crushed into infinite density at the singularity. And even if, by some miracle, you survive the fall, there's no coming back. So unless you have a death wish or a fascination with the unknown that outweighs basic survival instincts, your best bet is to stick to watching sci-fi movies about black holes instead. If you enjoyed this mind-bending space adventure, don't forget to like, share, and subscribe.